Okay, I'm sorry. Yep, here's a summary. Here's a summary, chapter 9. Additionally, 10 and 8. And 8 is at the bottom. It's for the confidence interval. So, um, we finished. We finished chapter 8 and 9. But let me summarize. Let me summarize the chapter 8 and 9. In chapter 9, we discussed the confidence interval, right? I have to, yes. It's basically, in chapter 8, chapter 9, we had one population mean. So we had, yeah, please look at the, it's a chapter 10, is later, right? But in chapter 9, 8, we had only one population mean. So we had one sample mean, and we defined, it means it has, yeah. So let me make a statement. The X bar has normal distribution. The mean was, yeah, is equal to unknown population mean, and the standard deviation was sigma over square root of n, right? It's actually, we got this one in chapter 7. In chapter 7, yeah, we discussed the sampling distribution of the sample mean. So we had the normal distribution with the mean and the standard deviation. So based on the mean and the standard deviation, yeah, we plugged the x bar here, right? And now it was this. Good, right? And also we plug x bar here, and I'm so sorry, it is not easy to make a note on a table, right? Yeah, but yeah, that is, yeah, denominator. Okay, yeah. But when we don't know, when we didn't assume, yeah, we knew the sigma, then instead of the sigma, yeah, we have to use the S, which was the sample standard deviation, and it was here. And definitely, we have to take the t-score. And now here, we applied the p-value approach from the z-table, but the t-test, yeah, we got the critical values. Yesterday, yeah, we got the critical values as it depends on the left tail, right tail, or two tail. And we made decision and the conclusion. Okay. Yeah. So please remind chapter 9 and chapter 8 together. Yeah, it's absolutely it's everything from the normal distribution. It's actually from the sampling distribution of the sample mean. It's from chapter 7. Any question? Excuse me? Absolutely. Yes. One day, in exam number 1, I gave you my summary. Yeah. It's absolutely, you can bring it. And did you keep your summary? Exam number 1, 2, 3? Yeah, you can bring again. And additionally, yeah, you can make your summary more. And absolutely, you can bring my summary. Yeah. Okay, today we are going to discuss chapter 10. Yeah. See, the chapter 9, the title was the hypothesis test for one population mean. And I added Unknown here. How many population means? Only one. Inference means the hypothesis and confidence interval. It's a together. That means it's a conference. I'm sorry, the inference. But now we have a two population means. Population means absolutely unknown. It's unknown. Two population means now here. So now we have two populations. So let me numbering. It's a population number 1, and here is the population number 2. As everything is a pairs, we have a population mean number 1, mu2, population mean another population mean from the population number 2. It's a mu2. And also, we have a sigma 1, population standard deviation number 1, sigma 2, another population standard deviation number 2. Okay, right? Absolutely, we have two samples. Here's a sample number 1 from the population number 1. And we have the other sample number 2 from the population number 2. So we have a x1 bar. How do you think? What is the name of this? Sample mean number 1. And the other one, x bar 2. The other sample mean number 2. How about the S1? Sample standard deviation number 1. S2, sample standard deviation number 2. Additionally, N1, N2. It's everything from the two groups. From the independent, see, independent two samples. So we are going to take the difference. We are going to focus on the difference. So the question will be, how much will be the difference? And that will be the null hypothesis. Yeah. If the two population means mu1 and mu2, if they are same, how much should be the difference? 0, yes. If mu1 is much bigger than mu2, what will be the sign of the difference? Is it positive or negative? What did I say? Mu1 is much bigger than mu2. What will be the sign of the difference? Positive, yes. The other way, mu2 is much bigger than mu1, the difference will be negative, right? Yeah. So it's basically we are interested in the difference. It's between the two means, right? Yeah. Absolutely, we are going to take the another difference between the two sample means. So the null hypothesis will be the population mean difference. The difference between unknown two population means is equal to 0. I told you in the null statement, always equal sign. What do you expect in alternative hypothesis? We are going to have 3 inequalities. Yeah, it's the same. It's the same. Look at this. Here is the inference. Here is the inference for unknown. Yeah, don't forget unknown. two population means using the independent two samples. We named it will be the pooled t-test. When you read the textbook, absolutely we have a z-test, right? But I don't want to take care of the z-test. We are going to take only the t-test. Absolutely, it is almost the same idea. Do you remember the z-test and t-test before? Yeah, I gave you the summary. Yeah, the t-test and z-test is almost the same. It's the same thing. In chapter 10, when we have two groups, two populations, the z-test and t-test is almost the same. So I don't want to take care of the z-test in chapter 10. Yeah, that will be as similar as between the z-test, t-test in chapter 9, right? Yeah. So we are going to look at the summary later again, but now, yeah, please look at this. So we are not going to discuss the z-test in chapter 10, but we discuss only the t-test. But please read the textbook. Yeah, there are so many other topics. Yeah, I do not take care of all of them. Only take care of the pooled t-test, right? See? I told you we are going to compare, we are going to take the difference and set up the difference will be equal to 0. But simply, I just add mu2 in the left-hand side and add another mu2 in the right-hand side. Then we take the statement. Mu1 is equal to mu2. And I told you when mu1 is equal to mu2, then the mean difference must be 0, right? It's the same thing. So this statement is the same as this. And what will be the alternative hypothesis? Not equal to two tail, less than left tail, greater than right tail again. It's almost the same. What's the difference? Now in chapter 10, we have two population means. That is only the difference. Still, in the null hypothesis, there is an equal sign. In alternative hypothesis, not equal to, less than, greater than. Three kinds of inequalities. How about the step 2? Same. We have to look for the significance level, alpha. Step 3, absolutely, we are going to take the test statistic. Oh my God, don't look at this. Just a copy. Yeah, please just a copy. See, I'm so sorry. It's very difficult. Yeah, it will be very long calculation to get the test statistic, right? But just a copy. Yeah, carefully, just a copy the test statistic. Yeah, because we have two groups, two sample means, two sample standard deviations, and two sample size. Yeah, it must be, it's complicated. So in a long calculation, yeah, we are going to take the t-score. What do you expect? Step 4. It is a t-test, right? Before, in the t-test, we found p-value or critical value. We apply the critical value approach. Yes. So, yeah, it's not here. Yeah, let me add step 4. It's a critical value approach. So we are going to take the critical value from the t-table because it is a t-test. Remember, what was the name of the procedures? Pooled t-test, right? Then step 5, yep, it's a pooled t-test. Then step 5, make the decision. And step 6, conclusion. It's the other way, is interpretation. Yeah, it's the same thing. Pi, it's a little bit different. It's a little bit different 6 steps. Yeah, we are going to apply the pooled t-test. It is only the difference because we had 2 populations and 2 samples. So do you have an idea? Yeah, we are going to apply the pooled t-test in many examples, but you have to understand what's the difference and what is the same thing. Yeah, the 6 steps. It is yours. Yeah. Oh, I don't know anymore. Yeah, but I give you the credit. Thank you. Okay, so please understand the idea. Yeah, it's almost the same, but we have 2 groups. Okay. So please look at this example. In this example, we have independent 2 groups. One is the private school, the other one is a public school. And we compared the mean salary as a mean salary of the college faculties. Absolutely, from the private school is more than public school, right? But what is the claim? Definitely, yeah, it's a numerically, it is bigger than this one, right? But we want to test if it is really, statistically, is larger than the others, right? So that is the question. That is the claim, right? So now at the end, yeah, here is the claim. At 5% significance level, do the data provide sufficient evidence? What? Differ. Do you have an idea? How can you state alternative hypothesis from the differ? Okay, let me try. Step number 1. See? In chapter 10, when we compare 2 groups, always we stated the null hypothesis like that. As mu1 is equal to mu2. And now we compare the mu1 and mu2 is again. What will be inequalities in alternative hypothesis? We had 3 choices again, not equal to, less than, greater than. Which one? Why? Differ. It's not equal to, yes. Two-tailed. It's not equal to. It makes sense, right? Step 2. Alpha. Significance level. Can you see the significance level? 5%. 0.05. Okay, let's do it. Did you copy the formula? You know, t-score was, we have to take the mean difference, the sample mean difference, and we need the SP. Yeah, we have another equation for SP later, times 1 over N1 plus 1 over N2. And then what was the SP? SP was, you know, S universally S for the standard deviation. So we have to take the square root of it. And 1 minus 1, S1 square, S2 minus 1, S2 square, and 1 plus N2 minus 2. I'm genius. I can memorize any formulas. Yeah. It's kidding. I'm not. I will explain to you. I will give you the idea. why we have to take the SPs like that. But anyway, let me plug the formulas, let me plug the values into the formula. Okay, square root of, first of all, N1. How many sample size from the private school? N1. Can you see that? 35 minus 1, times, can you see S1? The standard deviation in sample number 1. Give me the S1. 26.21. But we need the variance square. Add. Can you see the other sample size? N2? 30 minus 1, times. Can you see the other sample standard deviation? 23.95 square. In the denominator, we plug the N1 and N2 again. 35, 30 minus 2. Be careful. It takes time. Yeah, I understand. So take your time, slowly. Take the numbers. Can you give me the numerator? How many must be 35 minus 1? Yeah, simply just plug the 34 times 26.21 square. I have 23356.7794. Second term, how many will be 30 minus 1? 30 no. 29. 29 times. And the second term will be 16634.4725. And then divided by 35, 30 minus 2. That is a 63. You know, when you do more practice, then the calculation will be faster and faster. But now, please take your time and slowly you can get the part by part, right? So let me take the numerator. Let me take the addition. I got 23356.7794 addition, 16634.4725. I have a numerator is a 39991.25 is 19 over 63. Then inside of the square root, it must be 634.7818. Oh my god. Finally, let me square root of 634.7818. Finally, it will be 25.1949. Did you get 25? It's a 25 point something? Am I right? Exactly same? Exactly same? Is it a test statistic? I'm so sorry. It is not a t-score. It is not a test statistic. It is just the SP. Let's get the t-score. Okay, the t-score is here, right? The t test statistic, yeah, we have to get the sample mean difference. 88.19 minus 73.18. And now in the denominator, we plug the 25.1949 times 1 over n1 plus 1 over is a 30. Another long calculation. Yeah, let me take the sample mean difference. Numerator, 88.19 minus 73.18. 14 point is 92. And the denominator is a 25.1949 times square root of 1 over 35 and 1 over 30. So the denominator will be 6.2687. Okay, let's get it. 14.92 over 6.2687. The test statistic will be 2.38. Yeah, yeah. Numbers, 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 number, 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 and number, and also numbers, numbers, and finally, the test statistic t-score is a 2.38. Any question? Yep, take a picture. Okay, another page. I need another page. Oops. Yeah. Yes, here. What next? Critical value. Step 4. Step 4, we need a critical value. Remember, critical value. We have to get the critical value from the t-table. From the t-distribution is mean equals 0, right? We plugged the alpha. We plugged the significance level. How much? Yes.
Is yours on the T?
2 point.
80.19 minus 7, is that 15.92, right? I'm getting 15.
Oh, I'm wrong. Thank you. 15.01. Then what will be the test statistic?
I got 2.394.
2.394. Thank you. Yeah, it is a better answer. 2.394. Thank you. Okay, for the critical value, we plugged the alpha. How much was the alpha? 5%. Was it left tail, right tail, two tail? Which one? It was two-tailed. See? Then what should I do? We got alpha was equal to 5%, and we had two-tailed. Then we split half and half into the two-tailed, right? So I have to put here half and half the alpha, 5%, half, 2.5% and 2.5%. Bless you. So let me go to the t-table. Okay, so please look at the t-table. See? You know, the t-table gave us right tail. But already we split it half and half, 2.5%, 2.5%. So we need only the right tail, 2.5%. Which column? In the middle. Oh, now we need a degree of freedom. That is the problem, right? Please look at the picture here, the very beginning. the very beginning on the first page. Yeah, in chapter 10, we have two populations and two samples. Two sample means two samples and division and two sample size, and one and two. We remember the degree of freedom in chapter 9 was n minus 1. But now we have two n's. So even we apply this n minus 1 on both, we had two n minus 1s, and 1 minus 1 and 2 minus 1, right? Okay, good. So we have n1 minus 1 and 2 minus 1. So 2, it is not a degree of freedom, but yeah, n minus 1s, right? Any idea? How can I take care of them? To get the degree of freedom in the pooled t-test. Oh, good idea. No, don't take the average. Simply just add it. Yeah, simply just add it. Sorry. Average is a good idea, but take just sum, right? So now, let me try here. N1 minus 1, N2 minus 1. 35 minus 1, 30 minus 1, and 34 and 29, what? Simply just add. Huh?
We've already done it.
We did?
Yes.
Where?
The SP equation, 35 plus 30 minus 2.
Yes, it is the new degree of freedom. How? Don't take the average, but simply just take the sum. Yeah, it will be n1 plus n2 minus 2. Where did you get negative 2? Minus 1 and minus 1. It will be 63 in the denominator. Do you remember where was n minus 1 before in chapter 9? You know, here's a blank here. We had, in chapter 9, we had S in the t-test, which was summation of xi minus x bar square over n minus 1. The degree of freedom, n minus 1, was in the denominator. Of whom? Standard deviation, S. Exactly same. Where was n1 plus n2 minus 2? It was in the denominator. Of whom? S. Sample, standard deviation S. Yeah, exactly same place. It will be the degree of freedom, 63. So let me go to the t-table. Yeah, we need the t-scores from the middle column, and the degree of freedom, we got 63. So going down, the next page, 63. So here's the 63. In the middle, there is the t-score, 1.998. Does it make sense? 1.998. So here is the negative 1.998, and there is a positive 1.998 because we had two tables. So we can make the three partitions less than negative 1.998, greater than positive 1.998, and between plus and minus 1.998. Where we can reject the null hypothesis? In the two tail, right? Yeah. Reject the null, reject the null. However, in the middle, not to reject the null hypothesis. Okay, we set up as everything forward. Step 5 is make the decision. How much was the test statistic? In a long calculation to get SP and T, 2.394. Where is the test statistic? 2.394. Here, test statistic, 2.934. In the right tail, we have to reject the null hypothesis. Which one should I interpret? At the beginning, now the decision, step 5, reject the null statement. Finally, in step 6, we have to make the conclusion. We rejected the null statement. Then which one should I interpret? Basically, we had two statements at the beginning, step 1, the null statement and alternative statement. And now we reject the null statement. Then we should interpret what? Greater than, we interpret alternative hypothesis. No, not greater than, not equal to. Because we have to interpret as based on alternative hypothesis. And the alternative hypothesis said different. It's different. So we can make the conclusion they are different. What they? The mean salary. The mean salaries are different. I want to say unfair. It's unfair. Anyway, they are different because we have to interpret from the alternative hypothesis, because we rejected the null hypothesis, because the test statistic was in the right tail. Does it make sense? Right? Good. Yeah, we need to practice and practice and practice. Try it. I told you always, step number 1, the null hypothesis, always mu1 is equal to mu2. And the alternative hypothesis, we had 3 choices. Step 2, you can look for the alpha. And you have to try by yourself to get the test statistic. And first of all, we need the SP. It's n1 minus 1, s1 square, n2 minus 1, s2 square, and 1 plus n2 is minus 2. And then you have to take the t-score, which was from the sample mean difference, SP times 1 over n1 plus 1 over n2. first of all, what is the inequalities in alternative hypothesis? Fraud was defined as sample number 1, right? And the claim was the service time fraud less than left tail. So it must be less than the left tail, right? And did you find the alpha? 1%? 0.01. Okay, let me try. Let me try to get the SP. Yes.
Between n minus one, n1 minus one, and then the s-squared, is that a time between those two?
Yes. And 1 minus 1, 9 times 4.90 squared. Yes, that is a multiplication. Here's a Here's a multiplication, and here's the multiplication also. Am I right? SP 4.77. Did you get 4.77 for SP? Please let me know if you didn't get 4.77.
After squaring it?
Yes. Before square root, inside the fraction must be 22.76. How much did you
I don't know, 2.
try? Try again. Okay. Okay. You have to take square. 4.9 is square. Yeah, you're square.
Yes, 4.77. Oh, I see.
Yeah.
Okay.
I think so. Did you have the other?
The other equation.
There's the T. Do you have SP?
Oh, yeah.
I know. You saw the SP.
So that's like a deep-ish. Yeah. Plug into the t-squared equation. So let's take this person instead of leaving.
I have a test statistic, t-score, -4. Anybody? -4? -4 something? Did you get 4.77?
Yeah, I did it.
And the next one is we have to set up the decisions. Set up on the t distribution is mean equals 0. And alpha was 1% left tail. Right, yeah, good. And we make two partitions, left hand side, right hand side. Right? So we have to plug the alpha onto the left tail, 0.01. Then we have to make two partitions. It's the left hand side and the right hand side, where we can reject the null hypothesis. In the left, reject the null hypothesis. Right, not to reject the null hypothesis. But how much was the test statistic? No. Test statistic. 4 point negative. Here. It's a negative 4.058. The test statistic. What will be the decision? Reject the null hypothesis. So decision in step 5, reject the null hypothesis. Does it make sense, right? Then in step 6, which one should I interpret for the conclusion? We rejected the null statement. Then we have to interpret the alternative hypothesis. What it said? 1 is less than. What was the 1? The mean time served for the fraud is less than. Absolutely yes. Yeah. Don't shoot. Don't shoot. Yeah, it is longer. Right? Yeah. So yes, it is. Exactly it is. Yeah, without the question mark, it will be the conclusion. Step 6. The mean time served for fraud less than that for the firearm. Yeah, it's offenses. Absolutely, we interpret the alternative hypothesis because we rejected the null hypothesis, because the test statistic was in the left tail. Any question?
What did you get on the 4-step? What was our score?
Oh, I'm so sorry. I didn't get the T-score. I'm so sorry. Yeah. Because the test statistic was too small, so I expected, it must be, okay, I'm so sorry. I skipped. So let me go to T-table right here. And how much is the left tail probability? No. The left tail probability, we plug the alpha 1%. But now we need the right tail. But the t distribution is symmetrical, right? So we have to go to 1%, the second last column. It makes sense, right? Because we plug is 1%, but we knew the t distribution is symmetrical. So we have to go to the second last column, And how many degree of freedom? 10, 10, minus 2, 18. Negative, be careful, is a left tail, negative 2.552. I'm sorry, I skipped. So here must be negative 2.552. And now the test statistic is smaller than the critical value to reject the null hypothesis to interpret alternative hypothesis. Good, right? Thank you. Any question? Okay, let's do the quiz number 19. It is the quiz number 19. Just a second. Yes.
Why would you teach for 2.552 if our alpha was 1%? It wouldn't be 1% divided by 2.
No. See? Yes. For the two tail, we have this split, but we stated. Why did you state this two tail? See? Less than. Not equal to, but less than, and it is the left tail. Okay, and now 1% is must be here, but the t distribution is symmetric. Here's a 1%, that is here's a 1%. Right? It's a 1% and copy 1% here. And the degree of freedom, the denominator, you have to take the whole square root of the fraction. And the denominator is 18. It's 18. But remember, we need the t-score here. That is negative 2.55. And you correct left the tail, just left the tail. So just to the right hand side, we do not reject the null hypothesis. Only the left tail is rejected.
Okay.
I think it is right tail. Good, right? Right tail. Because the 45 is a sample number 1, and is unfortified is sample number 2. So the claim was the fortified one, it's a more than unfortified. So it must be right tail. Hmm?
36.14.
What? ST? Anybody who got ST?
I got 7.3779.
7 point. How much did you get?
I got a big number. I got 1.
Oh my god.
That's what I did.
What?
That's what I got too.
How much?
1,306.36. Oh, that's what she got too. But the square root of it.
Just a second. Let me try.
Oh, I didn't square root.
I didn't get the square root yet.
I didn't
That could be why.
Okay, please.
36.
Okay, so finally what?
Did you get 36.1? Yeah. 36.
36? 36 point?
144.
144? Who got 36? Okay, good.
I forgot the square. Me too.
Don't forget the square root. It is S. Stella, did you get
I
that?
only squared the top.
Ah, okay. Okay. Then now we plug 36.144 here to get the test statistic t-score.
Is there an easier way to do the bottom of this thing on my what you're showing?
Yes.
Because it makes me break it all the way down and it takes forever.
It's not on that one. I wrote it on the back. It's
C
plus.
plus
That page you
1 over and then and then multiply. You know, so it's
It always makes me break it down.
but you can continuously. It's more and more additions. So now first you start is 1 over 14 and continuously 1 over 12 times square root times ST 36.144. Anybody who got the denominator for the t-score, the test statistic? Let me double check.
How many decimals?
4 is more better. Yes, 14.21.
Okay. Because it usually makes me break it all the way down and it takes forever.
14
The denominator is a 14.2190. I have a denominator 14.219.
So the top would be 7.4.
Mm-hmm.
And then I got 0.520.
Looks good. .52. The test statistic is a 0.52. 5% right tail. Yes, what?
When we find the t-score
Huh?
number,
What?
when we find t, that equation right there,
The t equation was
it's that one, right?
x1 bar minus x2 bar sp 1 over n1 plus 1 over n2.
Yeah. So, what do you do
The next part?
with the number? What do we do with the number? 0.52.
Yeah, just a second. Now then, we have to make the decisions. So now, step 4, the critical value. Based on t-distribution is mean equals 0. And 5% right tail. We have to go to t-table. 5%. And how many degree of freedom? 24. 1.711. The critical value will be positive 1.711. Where we have to reject the null hypothesis? To the left or to the right?
Rejected.
Reject. To the right, because we had right tail greater than. So to the right, reject. To the left, not to reject the null hypothesis. Absolutely. Yeah, we set up is everything. And now let me plug the test statistic. How much was the test statistic? Only 0.52. What will be the decision? Do not reject the null hypothesis. Do not reject the null hypothesis. Which one should I interpret? Which one should I? The null. What does it mean? Same. Same. What's the same? It's no differ. Yes. The drinking, even though we are drinking the fortified orange juice, it does not reduce. It does not reduce the PT. What's a P? Whatever.
Reduce the same.
It's the same. The reduced rate, same. Can you make the conclusion? No difference. It's no difference. We don't have to pay more. It's the same thing. It's the same, the reduced rate. Yeah, please make the conclusion. 10 minutes break.
So the
Yes.
test of statistics was less than the critical value?
Yes, you are right, but I didn't explain to you like that way. Before to make a decision, please make the rejection reason and non-rejection reason. Because we had right field. So to the right, we are going to reject the null hypothesis. But to the left, it's not reject the null hypothesis. But now, plug the test statistic. Finally, yeah, you're right. Finally, the test statistic is less than the critical value, so we do not reject the null hypothesis. But the other way, my explaining was because the test statistic is in the non-rejection rate. So we are not going to reject the null hypothesis. It's the same thing. It is the same thing. But the reason why